Hi, this is Lena, and together with my colleague Raghav, we did exercise 4 for Internet of Things for winter semester 2024-2025. For us, this exercise is still a work in progress. We have not been able to complete all the requirements until the deadline. However, we would like to give you an update of where we are in the process and what we still need to finish it. So let's look at our design choice first. We decided that the controller is going to be the server and the door is going to be the client. Primarily, it's because it's going to be straightforward. That way, there is a simplicity of communication flow. So the door just says, "What should I do now?" and the door would respond with "open," "close," or "do nothing." And with this polling model, it's simply easier to implement than if the controller is just trying to push commands out to the door. Another reason why we chose that design is because this way we're reducing the complexity on the door. The door is already handling the distance sensor, it's already handling the LEDs, and in real life, that will be motors. This way, we are only making sure that it needs to make occasional HTTP GET requests and does not need to maintain an open connection. And as far as the internet connection goes, they were both connected to the hotspot of my laptop. We lost quite a lot of time in our design when trying to program sort of a bi-directional communication between the client and the server. So in the end, we settled for a much simpler design without threading and without asynchronous programming. So the solution was that the door will simply regularly request the controller's current command by setting the get request, and the controller just needs to respond with the current command in JSON format. So either open, closed, or none, and then the door would simply react accordingly. As far as our setup goes, and you can see it's very simple. On the left, we have the door with the ESP32, and on the right, we have the controller with the ESP2866 with the switch and two buttons and the one LED. So let's take a look at the code that runs on the door side of the system. It starts by connecting to Wi-Fi and then it continuously measures the distance using the ultrasonic distance sensor. So if someone approaches closer to 11 centimeters or if enough time passes, it sends a simple HTTP request to the server, the controller in our case, asking what it should do next. And the controller can respond with open, close, or none. When the door receives the open, it simulates the door opening by lighting up the LED for 5 seconds. Then nothing happens for 5 seconds. And then when the door is closing, the red LED lights up for 5 seconds. If a close command arrives during the opening or holding open, the door immediately begins to close. And if an open command arrives while closing, the door reverses and starts opening again. So intuitive. All timing in the code uses non-blocking checks instead of time delays, because that was something that was discussed in the forums amongst other colleagues, and it also helped us. We managed to set up the server, and we got the Postman running. The HTTP GET requests were working perfectly. However, once we attached the ESP8266 for the server, we simply couldn't get the post requests on that microprocessor to work, and that is where we kind of stood still because we didn't simply have enough time to finish the debugging. So at the end, we got the code running and we got the server running. However, we were unable to put it all together with our breadboards, and that is where we are now. Thank you for watching. All of the code will be submitted in the zip file for your evaluation.